Hello everyone, this is your crash course for Intro Stats, and really the just basic need to know for intermediate statistics. So first of all, statistics is really the study of uncertainty. We're never certain about anything. We're not trying to prove anything. We're not trying to be 100% confident in anything that we do. It's really more about what is the likelihood of something happening, hence the probability of. We're trying to infer about this group from this group. We're trying to predict traits about different things, but we're never certain about anything. And so it's really seeing how confident we can be and studying uncertainty. There are two general purposes of stats. First, to describe a data set, and second, to infer something about a data set. So with descriptive statistics, we're talking about central tendency. That is fancy words for mean, median, or mode, typically mean, where we're just trying to measure where's the center of this data. Variability, typically we talk about standard deviation, is really talking about how spread out is this data. And so we're trying to measure center, and then we're measuring spread, and together those are starting to talk about the distribution of that variable or of that data. Also in descriptive stats, we talk about relative standing. So we have this distribution, we have this nice picture, and we say, okay, where do I stand compared to where do you stand? And comparing scores within the distribution. We don't really talk about relative standing much in intermediate stat, but we will focus very heavily on that center and spread. Inferential stats is what this course is all about. So we'll review t-test, and then we'll get into ANOVA later in the semester. We'll start with chi-square, and we'll get into correlation and regression next, and then circle back to differences. So differences is really talking about, is this distribution the same as this distribution, or are they different distributions? An association is looking at categories. So is there a connection between these categories? If I'm in this category, it might also tend to be in this other category on a different idea. Relationships are super fun where we're using continuous variables and we're trying to say, how do these variables move together? If this one increases, do we see a pattern of the other one increasing or decreasing together? And then we can use that to make predictions. So I can actually say, if I know these things about you, can I predict this other thing about you? Population versus sample. The big N versus the little n. You will probably get this wrong, and I will correct you. So chances are everything that you will be working with is a little n, not a big N, because the big N is the population. So population is literally everybody is included in your data set. Usually that's too large to actually do, and so we do a sample instead. This is where statistics come into play. So with population, we actually have parameters because we can know the low and we know the high. We have literally everyone in it. In a sample, we don't necessarily. We might get lucky and have the high and the low, but typically we don't. And so we describe this with statistics instead, which are estimates of parameters. It's definitely smaller, and we use lowercase letters. So if you happen to be dealing with a data set where you have everybody in whatever your population is, that's a big N. Otherwise, we represent it with a small n. A variable is this thing that we're interested in. It is something that we measure. However, it can be measured in lots of different ways, categorical, continuous, all kinds of different ways. But it is that concept or characteristic. When we're looking at a data set, these are the columns. And so whatever the column is, each one of those is a variable. There are two types, and we'll review this a little bit later when we get into regression especially. But we could have an independent variable and we could have a dependent variable. Generally, an independent variable is not changed by other things you're trying to look at. It's independent. And a dependent is the thing that depends on other things. Typically, our dependent variable is our gold nugget. It is the thing that we are so excited about and that we're really wanting to measure, and we're wanting to see is it affected by other things? So is it connected to something else? Is it associated to something else? Can I use it? Can it be predicted by something else? Does it change based on something else? The dependent variable tends to be the meat of your research question. And the independent variables are the other things that influence that. There are levels of measurement. This is the first thing that you have to look at when you have data, because we need to understand what type of variable we have. This matters in every aspect of what we do with it. So first of all, is it categorical or is it continuous? If it is categorical, is it nominal, where there's zero order to it, or is it ordinal, where we have some order even though they're categories? We could also have continuous data. Continuous data, there's two options, but I really don't care. I just want to know, is it continuous, or can we treat it as continuous? So there would be equal intervals, potentially a true zero. There are variables that actually do not have a true zero. There are things that we estimate as zero, and there are other things that are not. But generally with continuous data, we want equal intervals between the values. So money is always continuous because the distance between $1 and $2 is the same distance between $32 and $33. It's a $1 increase. This one is also ratio because $0 is a thing, and we can also have negative dollars, as we all know. And we can break those down into decimals as well. So $1 can be broken down into pennies. It can be broken down into dimes, into quarters. There are different ratios within that. There are other variables that are discrete. So there's a limited option, but they're really whole numbers only. So number of kids in a household, you can't actually have 2.5 kids in your household. You can have 2 or you can have 3. This gets a little bit confusing because it also depends on how the data was collected. So I said money is always continuous unless I asked your income bracket, in which case I would have ordinal groupings there is an order to them. There are higher income brackets, but it is not truly continuous at that point. The difference would be if I asked for your raw income and you typed in a number versus I asked your income bracket. So if you type in a number, I can group those numbers into age brackets. But if I only asked your income bracket, I cannot make that continuous. We do the same thing with age all the time. Instead of asking your actual age, type in a number. A lot of times we say, are you in your 20s, 30s, 40s, 50s, whatever. A lot of times that's fine. That's all you need. But if you find a difference in the 30-year-olds, for example, you have no idea if that whole sample were 31-year-olds or that whole sample was 39-year-olds. So it's better to ask continuous information if you can, and then you can collapse it if you want to. So let's think about a different example. For those of you who have ever done a 5K or known anybody who's ever done a 5K or more, or any race, your start time would be nominal. It doesn't matter if you are all in the same category, you can have different start times just to space out the race. There is no order to that. Usually it depends on when you signed up and it doesn't matter. So that's nominal. There's categories, but there's no real order to the categories. Ordinal would be your race results. So did you come in first? Did you come in third? Did you come in second to last? It's usually where I am. Where were you in the rank of the race? So the problem with that is there's still categories. There's still an order to those, but the distance between them is not the same. So first place could be 30 minutes in front of second place. And then third place could be 30 seconds behind second place. So there's not equal intervals. Instead, we could say, what was your race time? And that changes to equal intervals. So I can compare first place, second place, third place based on their time, which would make it equal intervals. This is the hardest thing to do sometimes with data sets that aren't yours. So we really need to look at code books and understand what the data is. Just because it looks continuous doesn't mean it is continuous. One more thing here. If you have a Likert scale, those are technically ordinal, but we treat them actually as continuous. So we'll be using Likert scales as continuous, just assuming that they're equal intervals, even though we know they're not technically true. That brings us to unit of analysis. The other thing that you need to look at with a data set is, what is the data about? So where the variables are our columns, the unit of analysis is our rows. Generally, we're looking at person scores in social science, but that could be a school, it could be a district, it could be a site or a state or a country. There's all kinds of different units of analysis. So you need to find the ID variable and then figure out, like, what is this about? Is it about people? Is it about groups? What's the level of analysis that we have, and what is that unit of analysis? So these are our rows. All right, displaying data. We can display this all kinds of different ways, and it 100% depends on what kind of variable you have. So if you have categorical variables, you could do a table and fit a lot of information in a table. You could do a pie chart or a bar chart. Those are pretty much the options that we're going to be focusing on. Continuous data, we also have kind of two options, but there's four if you really wanted to. So we have a scatter plot, and we use this when we have two variables together, and we are trying to see how these two variables are connected. So in this example, grip strength related to arm strength, and we can see a very nice pattern here, where as grip strength increases, arm strength is also increasing. That does not by any means mean I can just grab one of those balls and sit there and work on my grip strength and get really ripped arms. Not really the case. And the same with arm strength. You can work out your arms all day long, but that doesn't necessarily mean your grip strength is going to just automatically increase. But we do see a relationship between these two. If we have one variable that we want to understand the distribution of, that's when we use a histogram. This looks like a bar chart, but it's not. So we have these bins, these bars, and as you get older, this is age. So as you get older, you spill into another bar. So here, once I'm 22 or whatever, I would spill here. Once I'm 27, I would spill into here. And all the way through until I'm 40, and then I spill into this bar. And so these are measuring how many people are in this range, this 20 to 22 range and through. So there is an order to these bars, and that's why they're connected. So you go from this bar to this bar to this bar to this bar to this bar. That's the difference between a histogram and a bar chart. If we go back to our bar chart, do you see the gap? That is quite literally because this one does not lead to this one, does not lead to this one. If you think about it this way, this is for when 60-plus-year-olds where they live. So they don't go from a home to a facility and then to a retirement community. There's no flow between these. They can go back and forth and all around. No connection. Histograms have a connection. We could do a box and whisker chart. You'll see these in journals depending on where you're reading. Sometimes it can be really useful to look at group differences, but generally we're not using that. And then technically you could do a stem and leaf plot if you wanted to, but that's not really that helpful, especially when you get lots and lots of data.